Welcome back. Tonight's lesson is going to be on unit rates. This is an extremely applicable lesson to your everyday life. I use these consistently, constantly, every time I go shopping at the grocery store. Some more vocabulary that we need to be focusing on. I know that we haven't really been doing a great job with our topic 1 vocabulary, but these words should be added in there as well, and we'll go over all the vocabulary words. We should be adding into here rates and unit rates. We've been talking about ratios for the past 2 lessons, and now we're moving into talking about rates and unit rates. The main difference between rates and ratios is that rates have units. The definition of rate says it is a ratio that compares quantities measured in different units. Within the definition of rate is the word ratio, but you really need to focus on the fact that rate has units. Then unit rate goes on to say is a rate for 1 unit of a given quantity. When a unit rate is written as a fraction, the denominator is 1 unit. The 1 in a unit rate is read as per. For example, if a car travels 120 miles on 4 gallons of gasoline, then the rate is 120 miles for 4 gallons. If I was to simplify this, I just divide 120 by 4. That's where I get the 30 miles and then 1 gallon. They're rewriting it 2 ways. You can leave it as a ratio with units, which is a rate, or you can write it as 30 miles per gallon. Both of those would be acceptable ways to write your answers. Number 1 says that a lobster molts or sheds its shell 20 times over a period of 5 years. How many times per year does the lobster then molt? The rate that they gave us was 20 times in 5 years. We like to put the years or time, anything that's a length of time, we like to have that be our second quantity, so that's why I put that first. I know it says from left to right, 20 to 5 as well, but I went with that. To get a unit rate again, all you need to do, if this was a more complicated problem, you would just divide 20 divided by 5. So we're going from a rate to a unit rate, and we get 4 times per year. You can write your answer like that, or 4 times, again, per year is completely acceptable. You don't have to have both. You can have either one or the other. Go on, try 2. My final answer was 73 heartbeats per minute. Again, to get that 73, all I'm doing is dividing 219 divided by 3. You can use the calculator or you can show the long division on the side. Next, we have another definition very similar to unit rate. This one, though, involves our favorite thing, money, money, money. Money. Unit price. It is a unit rate that gives the price of 1 item or the price per item. Again, this is what I would really be using when I go to the grocery store. If you ever notice the price of the item, they'll have the price of that 1 item, and then they'll also have another unit price there to help you figure stuff out. So they're telling us here that the rate is $25 for 4 tickets. The unit price would then be $6.25 for 1 ticket. If we look right here, the 25 divided by 4, I know 4 doesn't go evenly into 25. 25 divided by 4, I'm going to get a decimal. It's fine. It's money. No big deal. So it comes to $6.25 per ticket. So notice they've written it 1, 2, 3 different ways. And all 3 of those are completely acceptable. On the back, we'll do this first example together. It says, your class is tie-dyeing t-shirts to sell for a fundraiser. You are in charge of buying the plain t-shirts. Which package is the best buy, and which package would then be the worst buy? So I'm going to start by labeling that this is shirt 1, this is shirt 2, this is shirt 3, this is shirt 4. When I set up to find a unit price, you always want to make sure that your money goes on top. You're always finding the price per item So you need the money on the top. So for shirt 1, it's $39 for 12 shirts. I will divide that out, and it comes out to $3.25 per shirt. Again, you're just a regular division problem. For group 2, it's $27.20 for 8 shirts. I'm dividing that out. I get $3.40 per shirt. Group 3, I have $47.25 for 15 shirts, which comes to $3.15 per shirt. Group 4, $21.90 for 10. Again, when you divide a number by 10, you just move that decimal point over one place to the left, and I'll get $2.99 per shirt. The question asked for the best buy and the worst buy. So my best and my worst. The best buy is going to be the cheapest shirt because it saves me money. So it's the better buy for me. So the one that is the cheapest per shirt would be choice 4 at $2.99. The worst would be the most expensive one, which would be the $3.40 per shirt. So that's choice 2. Go on, try example number 4. Sorry, before you start that one, we're going to put these into groups. I'm going to say that this is A, this is B, this is C, this is D. I think that makes this easier for us. So go ahead, pause the video. Very similar to number 3, just had to go through, use division, make sure you're always putting the money on top. I got my unit rate of $1.98 for A, unit rate of $2.09 for B, unit rate of $1.78 for C, and a unit rate of $1.81 for D. So the better buy, the best buy, will be, again, the cheapest one per ounce, which is choice C. We're going to move on to number 5. This one says that astronauts have different nutritional needs in space than on Earth. An astronaut's diet contains 18 milligrams of iron for 2 days. How many milligrams of iron should the astronaut's diet contain for 9 days? There are multiple ways to solve this problem. A lot of you would like to probably go ahead and figure out the unit rate of how much he needs for 1 day, and then you can multiply. That is the way that would be suggested since this is the topic. Or, again, you can set up a proportion. Either one is acceptable. If we wanted to first figure out how much he had per day, it would be 18 milligrams divided by 2 days would tell us that his unit rate is that he needs 18 divided by 2, 9 milligrams per day. If he needs 9 milligrams per day and he's traveling for 9 days, you can also use conversions here to kind of know what operation to do. If I have 9 days times the 9 milligrams per day, that allows me to cross-cancel my units, and I can clearly see that I would multiply to get 81 milligrams. I know that might seem unnecessary to some of you, but you can certainly go ahead and solve it that way. You guys are going to go ahead and do number 6. Go ahead and pause the video. In this case, same deal. Figure out what my unit rate is. Then if I need to travel, I know how much he goes in 1 mile. The satellite actually goes in 1 minute. I then take that 284, multiply it by 3, and now I know that it goes 852 miles. Again, I'm just showing you with the conversion factor right here so that you can see how we are actually able to cancel out the units. Thanks for watching. We'll see you tomorrow.